Hey guys, so here's part 2 of the 5.5 notes. We are talking about adding and subtracting rationals. Now, we did some examples where the denominator was exactly the same, and so all we had to do was combine the numerators. But now we need to talk about, well, what happens when the denominator is not the same? Well, this is where we talk about finding the least common multiple between the expressions. Now, when we need to find the least common multiple with rationals, the first thing we need to do is factor each expression. Okay. So our two expressions here are 4x squared minus 16, and then the 6x squared minus 24x squared 24. So the first thing we need to do is we need to factor. Now, the first thing, let's look about the 4x squared minus 16. The first thing I see that both the terms have a 4 in common, so I'm going to go ahead and take that out. So I'm left with x squared minus 4. Now, I still need to see, can I factor more? Yes, x squared minus 4 is a difference of squares. So that means I'm going to have x plus 2 and x minus 2. Okay, now let's go ahead and factor the 6x squared minus 24x plus 24. So the first thing I need to see is, do these three terms have anything in common that I can take out first? Well, yes. They have a 6 in common. So I'm going to go ahead and take that out, and I'm left with x squared minus 4x plus 4. Now let's see that x squared minus 4x plus 4. Can I factor that a little bit? So remember that since our a value is 1, all I have to do is look at my constant value and talk about the numbers that multiply. And then if I look, well, I know 2 and 2. If I subtract both of them, they will give me that negative 4. So I'm going to bring this 6 back down. Now x minus 2 and x minus 2. Okay, now this is where we need to find the least common multiple. So we're going to say the LCM, okay? So the idea is that we want to make sure that this least common multiple, this would be in our denominator. So we need to make sure that everything has the exact same thing, okay? So let's first talk about maybe the numbers. Let's talk about 4 and 6. Okay. Well, what number that these two can go into? The smallest number that we can think of. Well, that's probably going to be, I think, 12, right? Because if we think about 4 times 3, that gives us 12, and then 6 times 2. So the smallest number that 4 and 6 can go into is going to be 12. Okay, now notice, on my first expression, I have an x plus 2. Now notice the other expression doesn't have it. So that means I have to have it as part of my least common multiple. Basically, the idea is whatever one expression has, it has to be part of the least common multiple. So I'm going to have my x plus 2. Okay, now I have an x minus 2. Now I need to see, does the other expression have it? Okay, yes it does. So we're definitely going to have that. But now notice, on my other expression, I have 2 of them, okay? So when you see that both expressions have the same, factor or number or terms, okay, when they have the same terms, it has to be part of the least common multiple. But if one of the expressions has more of that term, you need to include that in the least common multiple. Basically, the least common multiple is going to have everything that you see from the first expression and the second expression. It has to be included. Well, that means we have to have actually 2 of the x minus 2's. Now, to write this, you could just write x minus 2 again if you want to, or you can write it as a square to really indicate that you need to have 2 of those factors. Okay? So now that we kind of took everything that we see from both expressions, now we have our least common multiple. So as I said, or I'm going to kind of say it again here. So anytime in your expressions, if you see something, it has to be part of the least common multiple, no matter what. And if both expressions has it, then that'll be part of the least common multiple. And if one expression has more of that term, factor, number, whatever, then you need to include that much into your least common multiple. Okay, well, let's go ahead. Let's do an example here when we have to add. So let's look at 7 over 9x squared plus x over 3x squared plus 3x. Now, the first thing we always have to do is factor. So let's look at the numerator of our first fraction, 7. Can't factor that. 9x squared, you can't factor that because that's a monomial. So remember, anytime you only have one term, you can't factor. Okay, the x in my second fraction in numerator, can't factor that. Now the 3x squared plus 3x, I do see that they both have a 3x in common, so I'm going to go ahead and take that out, and now I'm left with x plus 1. Now my next step is to find the least common multiple. So LCM, okay? So now what I need to do is look at my two denominators. I have a 9x squared and a 3x x plus 1. Remember, whatever's in the denominator, that has to be part of our least common multiple. Now let's first talk about the numbers. So 9 and 3. So I would always separate your numbers, then go ahead with your factors or your variables. Now 9 and 3, what is the smallest number that 9 and 3 can go into? Well, that is going to be 9. Okay, now notice here we have an x squared and x. Those are basically the same term. Now notice though, one of them has more. There is an x squared versus an x. Remember, we have to have, when you have the same terms or factors, whatever, you always take the higher. So that means we have to have x squared, because that is more of them, right? That's x times x. Then lastly, we have the x plus 1. Since one of the denominators has it, we have to include it in our least common multiple, okay? Okay, now that we figured out our least common multiple, 9x squared times x plus 1, we need to multiply each factor by what's missing, okay? So let's look at the 7 over 9x squared. So we have 9x squared in our denominator, but what is missing there? It is the x plus 1. So I need to multiply the denominator and the numerator. Remember the same, what you do to the bottom of your fraction, you got to do to the top, okay? Now, on my second one, what am I missing? I got to get to a 9. So 3 times what gives me 9? Well, that's going to be 3. And I got to go from an x to an x squared, so I need to multiply by an x. Now, I already have that x plus 1, so that means all I need to do is multiply the denominator numerator by 3x, okay? So now I go ahead and rewrite, and we do some adding. So in this case, I think we're adding, right? Yeah, we are adding. So I'm just going to put add here, okay? So either that's going to change you either to add or subtract, just depending on what you're doing. Okay, so on my numerator, I have 7 times x plus 1. Now, I'm going to go ahead and show all of the steps. Once you kind of get used to this, you can not show all of the steps, so you don't have to, but just to make sure, because these are notes. So I have 7. I'm going to kind of rewrite this, especially if we have to do any distributing or multiplying. And then in my denominator, I should have my LCM, my 9x squared times x plus 1. Now, in our denominator, we are not going to multiply. We're going to leave it in factored form, because at the end, our final answer needs to be left as in factored form. Okay, then I have 3x times x, and I go ahead and do the denominator, because that needs to be exactly the same. So notice now we do have a common denominator, and now we can do some multiplying and then combining like terms. Okay, so I do my 7 times the x and the 1, so I get 7x plus 7 over 9x squared times x plus 1, plus I do 3x times 3, so that gives me 3x squared, and then I get my 9x squared, and then x plus 1. So now I go ahead and combine my numerators. Now, we don't have any like terms to really combine. We got a 3x squared, a 7x, and a 7. So I'm going to rewrite this in standard form. So my 3x squared, and then plus 7x plus 7 over, and then my denominator. Now, as I said, we need to make sure our final answer is in factored form. So it needs to be in factored form, or I guess you need to simplify. So final answer needs to be in factored form. Yeah. Okay, so that means we need to see if we can factor 3x squared plus 7x plus 7. Okay. So we do have an a value other than 1, so this is our trial and error process. So we have 1 and 3, 1 and 7. Good thing there's only one pair, so we only really have to do this twice to see what works. So I have x and 3x. So let's try 1 and 7 and see if this works. We got to get a 7 in the middle. So 1 times 3x gives me 3x. X times 7 gives me 7x. If I added or subtracted 7 and 3, that will never give me a 7x again. So this does not work here. Okay, so I'm going to switch that then. So I'm going to have a 7 and a 1. So 7 times 3 gives me 21x. And then I get an x. Well, 21 and x, that will never get me to a 7 if I add or subtracted. So really, my numerator of 3x squared plus 7x plus 7, I cannot factor that anymore, and there's nothing to simplify, so this is going to be my final answer. Okay, make sure you watch the next part. We're just going to continue to add and subtract rationals in which they don't have a common denominator.